Hello. I figured that since we're going to be doing a lot with logs and anti-logs in the coming chapters, that it would be a good idea to go over the rules for sig figs whenever logs are involved. Okay, and they're a little bit different than, addition and subtraction have different rules than multiplication, division. Logarithms are kind of a mixture of the addition, subtraction rule and the multiplication, division rule. So when you take the log of a number with a certain number of sig figs, we'll say n sig figs, the answer will have n decimal places. So whatever the sig figs are in the original number, that will be the number of decimal places in your answer. When you go the other way, when you take the anti-log of a number, the number of decimal places will tell you the number of sig figs in your answer. Okay, so the easiest way to go about this explanation is to just do some examples. So if I take the log of 0.0056, okay, if I punch that into my calculator, I get the answer negative 2.2518 and probably some more digits. The number of sig figs in the original number will dictate the number of decimal places in my answer. So whatever the number I'm taking the log of, how many sig figs are there? In this case, this number has 2 sig figs. Okay, so 2 sig figs in the number I'm taking the log of will tell me that I need 2 decimal places in my final answer. So if I were to give this as a final answer to the right number of sig figs, that would be negative 2.25. Okay. In chapter 16, we're going to be doing a lot of negative log of some value, because anytime we calculate the pH or the POH of anything, we're dealing with negative logs. And lucky for us, that doesn't change anything about these rules. So if I take the negative log of 6.93 times 10 to the minus 7, punch that into the calculator, and we get 6.1593 and some more digits. Okay. Same rule applies. In my original number, I have 3 sig figs. Right? So that means that in my final answer, I will be giving my number to the third decimal place. Okay, so the final answer here will be 6.159 to the correct number of sig figs. So let's go the other way with this. If I want to take the anti-log, so this is log base 10, right? And logarithms are just a way to do multipliers of 10. Same rules apply for natural log, right? So natural log is log base e, right? And we dealt with some of the natural log stuff in the previous chapter when we were doing rate laws and those sorts of things, okay? The rules are exactly the same. So if I'm dealing with log, L-O-G, everything's log base 10. So if I go anti-log, I say 10 to whatever the number is, okay? So if I'm going to do, let's say the pH of something is 4.25. And I want to know what is the H plus concentration. Okay, I'm going to say that H plus is 10 to the negative pH. Okay, so I'm taking the anti-log of the pH. So in this case, 10 to the negative 4.25. Punch that into calculator, and I get 5.6234 times 10 to the minus 5. Okay, so if I'm doing anti-log, the number of decimal places in the number I'm taking the anti-log of will dictate my sig figs. So 2 decimal places mean 2 sig figs, in my final answer. So if I were reporting this correctly, this would be 5.6 times 10 to the minus 5. Okay, so rules for logs are important, and I wanted to make sure I get this out there early because a lot of times mastering will make an issue if you are putting in too many digits or too few digits as far as sig figs for logs go. Enjoy!